Hello, everyone, and welcome to part 4 of Chapter 4's lecture. The learning objectives for this section are going to be to summarize how the senses of taste and olfaction transduce stimuli into perception, describe the process of transduction in the senses of touch and proprioception, and outline the gate control theory of pain. Explain why pain matters and how it may be controlled. All right, let's go ahead and discuss the different areas of taste, right? So we have sweet, sour, salty, umami, savory, and bitter. And start off with the first one, being sweet taste. Again, this is associated with sugars and foods that contain natural or artificial sweeteners. People describe it as something pleasant, and it can be found in things like candy, fruits, and desserts. There is a psychological connection to eating something sweet. These sweet tastes triggers the release of dopamine in the brain, and this is associated with pleasure and reward. And this is why we often find sweet foods enjoyable and comforting. Sour. Sour taste is very sharp, very tangy. It's often found in foods like citrus fruits, lemons, oranges. Vinegar and certain fermented foods have that sour taste. It can make your mouth pucker, right? The psychological connection to sour is that sour taste can stimulate saliva production and appetite. So some people enjoy sour flavors for their refreshing and that stimulating quality. Okay, where did we leave off? Right, some people enjoy sour flavors, right, because it's refreshing. It stimulates those qualities. The next one is salty. Salty can be described as having the presence of it's characterized by the presence of sodium ions in food. It can enhance flavors, and it's found in foods like salted nuts, chips, pretzels. The psychological connection to salt for our body, well, one, it's essential for bodily functions, but too much of it can be harmful, right? It can cause you to retain water, increase blood pressure, and while the physiological changes or effects, all that can actually impact you psychologically. So our preference for saltiness, it's partly biological. We do need it. But then again, it's also partly cultural due to habit and taste preferences. The next one is umami, right? Or umami. This is described as a savory taste. It's described as meaty, broth-like, or savory. And it's found in foods like meat, especially red meat, mushrooms, soy sauce, and some aged cheeses. The psychological connection to umami is that it enhances the flavor of foods, and it can make dishes more satisfying, more enjoyable. It's thought to signal the presence of protein-rich foods, which are very important in our diet. And then the last one is bitter. All right, so bitter taste is sharp, and it can be found in foods like coffee, dark chocolate, certain greens like kale and spinach. Never thought you would relate kale and spinach to chocolate, huh? And it's also found that taste is also found in some medicines, bitter medicines. The psychological connection to this is that bitterness, we associate that with something that's potentially harmful or some substance in nature. So it may be good that medications do taste bitter so we don't overdo it. We may instinctively avoid it. So I remember when I was young, I hated taking medicine. Today, medicine tastes great, I would say, compared to what they used to taste like. In the old days, they tasted like chemicals or something. It was bad. You did not want to take it. Today, people are just chugging down medications left and right because it tastes fantastic. So making the medications taste better, right? It provided some kind of psychological feedback for how we take medication today, or I think it does. Right? But if you understand these basic tastes, it helps us appreciate the variety of flavors in foods and how our senses of taste contributes to the things that we enjoy, and our nutritional intake, how healthy we eat. It can also show that our taste preferences can be influenced by biological factors, like with the salt, and in cultural experiences. All right, so let's get into taste and smell as far as these chemical senses. So taste and smell, these are senses that detect chemicals in the environment. Right? Environment. So taste detects chemicals in the food through your taste buds on the tongue, and smell detects chemicals in the air through the olfactory receptors that are in the nose. And together they help us perceive flavors and enjoy food. I don't know if you all did this experiment, but this is something you can easily do at home, where you can try to confuse your senses by smelling one item and eating another. So you can, let's say, cut a piece of lemon and eat, let's say eat an orange, right? Those one's very sweet and one's very sour. So you can take a bite of an orange as you smell the lemon, and you'll get the sensation that you are biting into a lemon, or vice versa, right? You can actually do it vice versa with some people, and so you trick your senses into thinking you're eating one thing over another. It's a nice experiment to do with the class, and just sort of break up information and see how our senses deceive us. I like to do this one experiment with classes where I ask them what their favorite Starburst flavor is, if they eat Starburst, or if they eat any candy that's multicolored. And most people will confidently tell me, you know, their favorite color and how they don't like one flavor over the other, and they really dislike this particular flavor, let's say of Starburst. And then I'll tell them that that really isn't their favorite flavor. And then in my experiment, we get a pack of Starburst. We cut them in small pieces because we don't want their taste buds to get too saturated. So we cut them in half. And then we blindfold them, and we give it to them randomly, and they have to identify the flavor. So they can't look at the color now. And they usually get them all wrong. I've had one individual who got them all right, and we even tried to trick that individual, and we could not trick him. And the interesting thing about him was that he aspired to be a chef. And I thought that was very interesting, because I thought, okay, maybe he has such a sensitive palate and he can tell the difference between tastes, that he experiences food differently than other people. And so for him being a chef, and for some food to taste a certain way, for him, he can actually taste it. And where most of us who don't have those sensitive palates, we couldn't taste it. So anyway, I just thought that was interesting. It's only one person I've ever met that we could not fool. And we tried. We went to the regular experiments, and we just tried to do a bunch of crazy things, and all kinds of variations to kind of hint him. And then we lied. In one case, we were deceptive, telling him that his guess was wrong, but he stuck to his answer, and he was actually right. We tried all kinds of things. He was very, very confident, and he wanted to be a chef. So I find that very interesting. Anyway, back to our lecture. When we talk about the human tongue, right, we have about 2,000 to 8,000 taste buds. You probably have way less when you eat a hot pizza and you burn your tongue with the cheese, but or at least those that are sensitive enough to taste the difference between tastes, right? So you got these tiny little structures on the tongue. They're taste receptors connected to cells, and they help us detect different flavors, like we mentioned before: the sweet, the sour, the salty, the bitter, the umami flavor. The structure of the taste buds, so each taste bud is made up of about 10 to 50 receptor cells, and these cells are sensitive to different chemicals in food, and they send signals to the brain which interprets them as taste. So again, all of this is just interpretation. Chemical receptors. So we're like little chemical testing machines, right? But because certain taste gives us pleasure, we look at this as something very enjoyable or very not enjoyable. As where if you have a chemical analyzer, it doesn't enjoy doing certain tests over other tests. It just tells you what the chemical makeup is of a chemical. But for us, we include this feeling about how we like a certain taste or don't like a certain taste. So this is why I do stress the affective, not this, but many other things is why I do stress the affective domain on top of the cognitive domain to try to understand behavior. So when we talk about individual differences in taste and sensitivity, people vary widely in their ability to taste flavors. So about 25% of people are super tasters, meaning they have more taste buds and they're very sensitive to flavors. Another 25% are non-tasters, meaning they have fewer taste buds and they're less sensitive to flavors. So the ones that are less sensitive, these might be people who just don't care where they eat, like they can have a hamburger, a pizza, whatever. To them, food is food. As we're someone who says, I'm in the mood for a particular type of salad from a very particular type of restaurant. No other salad from any other restaurant will do, because they have such a sensitive taste that when they say they want that flavor, they have something very specific in mind. So I find that to be interesting too in how we make decisions. But again, that 25% of people who are super tasters, I've come across one. It's interesting when you run across somebody like that. You can't fool them. And again, I did try to be deceptive, and at the end, the experiment was over. So we were just trying a bunch of different, tests, and being deceptive was the last thing we could do, and it did not fool the individual. Taste receptor cell replacement. Right? These taste receptor cells are constantly being replaced every 9 to 10 days. So old taste cells, they just die off, and you have new ones that grow to replace them. If you do something extremely crazy, like you eat super hot pizza or soup that's a little too hot, you'll cause damage and you'll burn them. And so what happens with this turnover process, it helps maintain the ability to taste and perceive flavors consistently throughout your life. But they do get affected through age, and your taste sensitivity actually changes. So as we get older, the rate of those taste receptor cells replacements, that slows down. That leads to a decrease in taste sensitivity, so it makes flavors less intense or noticeable. So older adults, they may find that they need stronger flavors or seasonings to enjoy food as much as they did when they were much younger. You might find that you didn't like certain seasonings when you were younger, and you say, well, I like it now. You may have been too sensitive to a particular type of seasoning when you were younger, and as you're older, it's not as intense. For me, I can't say this is exactly under this category, but I did not like onions when I was younger, especially raw onions or cooked onions. Now, I do enjoy the taste of onions. Cooked onions. I still don't like raw onions. But I can tolerate them. Right? In a hamburger with fresh cut onions in the burger, I'll still eat it. It's not that bad, but I still don't like it. But I tolerate it. So it's important to understand these aspects of taste and smell as well. It helps us appreciate how complex and important the senses are in our daily lives. We do this every day, and we go through our day with these senses automatically, detecting these chemicals in the air, chemicals in the things that we place on our tongue. They also they'll affect your nutrition. They might affect things that you want to eat or don't want to eat. Again, kids not wanting to eat their greens, again, because of the taste of spinach or kale and so forth. This can also affect your social interactions with people, if you prefer certain things over others. And again, the smell and the taste also is very, very important for us to determine when something is spoiled. Right? So that's part of our survival. And so the olfactory sense is, we call it olfactory nerve number 1, the cranial nerve, because it's the oldest nerve, and it's the first nerve, I guess. And this is a set of senses. All right, so let's go ahead and look at this diagram for smell receptors, and I'll go ahead and explain a little bit about them in the next slide. I'll just leave this here for a few seconds. You can pause the video and just kind of look at it. All right, let's continue. All right, so let's talk about the psychology of smell, or at least try to explain the psychology of smell. So you have these receptor cells, right? And they are in the upper nasal passage, and you have about 400 different types of receptor cells in the what's called the olfactory membrane, olfactory. Not ode factory, but olfactory. And the cells, they're specialized cells, and they're specialized to detect different odor molecules in the air, which is incredible if you just think about it, that we can smell these different chemicals based on their makeup. What is odor? You know, if you can just sit there and have a philosophical discussion on what is odor. But when we talk about the detection of these smells, right, even though we have only 400 types of receptor cells, our sense of smell is super sensitive. There's research that suggests that we can detect up to, I don't know if there are even, you know, a million different kinds of smells, but the combinations of different kinds of smells, I mean, it's way up there. That's all I can say. That's the only thing I'll say that I feel comfortable saying. Right? It doesn't mean that we've experienced, you know, let's say a million different types of smells, but the combinations of smells that we can actually distinguish if we were exposed to them and we could identify them is quite a bit. So different kinds of smells. And all of this because of the way the different receptors fire and the different patterns that they fire in the olfactory system. There's neural messages. So when an odor molecule binds to a receptor cell, it triggers a chemical reaction that sends this neural message along the olfactory nerve to the brain's temporal lobes. And this is where smell is processed and it's interpreted. We have a chemical sense, right? So I was going to say like a spidey sense, a chemical sense. And this is similar to taste, where smell is considered a chemical, and we sense it chemically. It relies on detecting specific molecules, but the molecules are in the atmosphere, in the air, and you know, we refer to them as odors. And so these odors in the environment, they create all of these sensory experiences. Not that I do this, but I've actually thought about trying to create one of these atmospheres, like in a room where we have all these different aromas that actually have a certain theme to kind of modify people's ability to relax or something like that. I've always wanted to see how well that works. There are a lot of smells that, like candles and all that kind of stuff, that I like, and some of them, like when I walk by the candle area in a particular store, where you'll smell one and just so good, and you think, wow, I could see this one working for me, or something like that. But then some of them are actually too good, where I just focus too much on the scent, and I probably would not relax or focus because I'd be so into the scent. Think of like sugar. You eat sugar, it's so appeasing. You get this dopamine rush. It sounds like it's a good thing, but you're focused too much on the effect that it's causing on you. There's something called the anosmia effect, and this is the inability to smell, right? So when you have like a head injury, or you have got congestion, your nose is clogged or whatever, you have this inability to actually to smell something, and you might or you just get saturated or used to a particular smell. If you've ever been to let's just say someone's home, and they have a very distinct smell in their home, but they live there and they don't smell it anymore. They think it's gone or something. You go in there and it's like, oh, what is that? I knew somebody who moved into a home, and the previous owners smoked so much. And of course, the person, my friend, he was used to it, so he couldn't smell the smoke anymore. But and he didn't smoke. When I walked into the house, you could smell the paint because the owners put a fresh coat of paint into the house, and the paint was very, very strong. So with my friend, I think it sort of just masked the smoke smell. But when I walked in, I could smell every single, like, there wasn't a area, a corner of the room that did not have a very strong cigarette smell. And he couldn't smell it. He did at first, and then when they painted it, he thought it went away. But no, when I went in there for the first time, it was strong. And he kind of said the same thing. It's like it was in the walls and so forth, but when they painted it, the smell went away. It's like, no, the smell did not go away. I think you got used to it. You can also lose your sense of smell because of certain illnesses. So that was something that happened with individuals who contracted COVID-19. That was one of the symptoms, loss of smell or loss of taste, or maybe just a decrease in the ability to smell, things, not everything, but some things, and the inability to taste certain things. So I don't know if you noticed this when it comes to taste during the COVID-19 pandemic. I'm not sure if this is related to the pandemic, to the COVID-19 itself, or if this is related to something indirectly like manufacturing. But cinnamon was out. You couldn't get cinnamon anywhere. I like those hot tamales, which are cinnamon flavored, and those red hots, the candy that's cinnamon flavored. Could not find those anywhere. And I went from store to store looking for them because I just had a craving for those. But they were gone. No one was selling them. I went to get those. There's these cheap generic candies that are cinnamon, but they're spicy hot and cinnamon, and there's other ones that are just cinnamon only. The only ones I had were the spicy ones, and I didn't like those, so I didn't buy it. But cinnamon was gone. It was hard to get the cinnamon flavored candies. And so I'm not sure if this is something to do with you just didn't have people at the plants working and they couldn't produce the candy, or they were being bought out. Like every time they showed up at the store, people wanted something that they could taste, and so they bought all the cinnamon candy. Again, it's just an observation. I don't really know why it happened, why I couldn't get red hots or why I couldn't get hot tamale candies. And I do love sour candy. It was hard to find sour candy as well. I had to order it online. And I like those warheads. Those are very impactful, I'll say. They're super strong, sour. And yeah, I could eat tons of those. But again, going back to anosmia, the loss of smell, it's believed to occur because, let's say you have a virus that inhibits substances that stimulate the growth and regeneration of those olfactory receptor cells. So if they're not regenerating and they're not rebuilding, and these cells typically regenerate every 24 hours, you start losing your ability to smell, right? So understanding the psychology of smell receptors, this at least helps us appreciate how complex and sensitive our smell is. It plays a crucial role in your ability to enjoy flavors. But more than that, evolutionary wise, it helped us detect danger. It helped us navigate our environment safely. And there's just so much more that's associated with smell and taste. It's also linked to memory. It helps us actually attach another piece of information to a piece of memory that helps you recall that memory much quicker. And solidifies that memory. So if you have memory associated with a particular smell or something of a particular taste, again, those two pieces of information that are connected to let's say a restaurant or a time or an event helps you solidify that memory, and you can recall it easier. So yeah, I always do something, not always. If you find yourself having a hard time concentrating and remembering, try to do something impactful while you're studying, and that'll kind of help you attach more stimuli to that memory that you're embedding. Temperature. Let's go ahead and talk about temperature. Temperature is just that sensation that allows us to feel whether something is hot or cold. Again, our skin has receptors that detect changes in temperature and send signals to the brain. From an engineering perspective, I just have to say, because I love endocrinology and the nervous system. The nervous system used to be my favorite system until I really got into endocrinology. But again, sometimes I go back and forth. The receptors that our body has to detect things like pain, pressure, temperature, it's incredible. I build systems, electrical systems, electronic systems with sensors that are, they're man-made sensors, and we use them to measure all kinds of things, and the electronics and the microprocessing that goes to get one particular large, sensor to work and do its thing. And our body is embedded with these things. It's just, our body is an engineering marvel. So hopefully you'll have a better appreciation for the engineering of the human body. Not just the human body, I mean every living organism, even plants. I'm super impressed with plants, and I'm super impressed with fungi. Their engineering is different, but it's still it's something we can't artificially create. Right? So it's amazing. It is just amazing. So we look at the psychological perspective of temperature. Right? So temperature sensations, these can affect our mood. I know it definitely affects my mood in summer because I hate the heat and the sweating here in Texas and San Antonio, even though I've lived here all my life. Now I just dread it. And I actually feel happier when the weather gets cold and it gets dark. Where most people tend to get depressed during the fall and the winter because they say that the sun is not as, we don't have as much sunlight during the day, and people tend to get depressed, and they become, they get that seasonal affective disorder, sad, when we go through fall and we go to winter. I actually have the opposite. I remember the heat for summer, and I compare that to winter, and I enjoy the winter, and I am happy. I am happy when it's cold outside. So it definitely affects my attitude, my mood. Again, that's something I can alter if I really wanted to find a way to enjoy summers. I'm tired. I'm not young anymore, and yeah. So yeah, temperatures can help you feel relaxed. They can help you feel comfortable. Who here can sleep in a hot, sweaty, muggy room, right? Not many, unless you're absolutely forced to, like you're in the military, and you just get sleep wherever you can. You don't really care because sleep is more important. But if you had the choice, you would want to be comfortable. Touch, we talked about temperature, but touch sensation, this allows us to feel textures. It allows us to feel the difference in pressures, the difference in vibrations. It involves these receptors in the skin that can detect pressure, that can detect texture, and these are specialized receptors for very, very light touch and vibration. So my sister, I'm going to talk about a side story here. My sister had adopted these children. One of them was blind, and she wanted me to learn Braille so that I could, help her teach this child how to read if they were able to. And so she gave me what they gave her at the adoption agency, right? They gave her these like an alphabet, chart with all the Braille on it, and then little things to practice and to start off reading. And so at first, when I was touching all the letters, it was extremely hard for me to understand, to feel the difference between the A, B, C, D, or anything like that. I just felt the bumps. But after a while, because I was practicing and practicing, I was able to feel the slight difference between one letter and the next letter. So I was really able to, just read letters, right? Read the alphabet or feel the alphabet. But what I found was my finger was so sensitive that it was irritating to touch anything that had texture to it, right? So the tiniest little thing was like someone yelling at you, but through your fingers. And so I stopped doing it because I was doing too much of it. I was trying to learn it very, very quickly. and my fingers became extremely sensitive to touch. I'm not that way anymore, but you got to like pace yourself, because my fingertips were becoming extremely sensitive to the differences in the different letters, and I thought it was a good thing. But then I realized that I became extremely sensitive. I didn't know how to shut it off when I was touching other fabrics or material, and so I was feeling this very uncomfortableness touching any other fabrics. And you don't think about that when you think of someone who's blind and they read through Braille, like having to go through that type of learning process until you experience it for yourself. It was extremely irritating and uncomfortable, right? So these kind of things help us navigate the world. We can also talk about body movement, the kinesthetic sense. And the way we explain this is that kinesthetic sense allows us to sense the position and movement of our body parts. So we have these receptors in our muscles, our joints and tendons. They send signals to the brain about the position and movement of our limbs. So you'll know what angle your elbow is at. You'll know how far it's extended from your body by looking at the angle between your brachia, your upper arm, and your and your axilla, which is like the armpit. All this information is being sent to your brain. So you do this without thinking. You are thinking, but it happens so automatic it feels like you're not thinking. And your brain just getting all this information and is doing it very, very fast. So all these sensors, just to give you this kinesthetic sense of what position you're actually in. Imagine someone who's they have their eyes closed and they're doing something like yoga, and you're telling them to get in a particular position for, I don't do yoga, but and then they know exactly how to do it, and they do it perfectly. They have their eyes closed. They don't have to look in the mirror, or they don't have to be given direction, because their body is actually giving them the right information. They know exactly where everything needs to be. Pain receptors. This is something that I'm sure we have all experienced. Right? So pain is actually super important for us. We don't ever want to be painless. I know people who talk about it's like, I never want to feel pain. I never want to feel discomfort. Well, physical pain, yeah, I know it's you don't ever want to repeat the things that cause you physical pain. And so it's a good learning signal that's attached to something that would teach us never to do that again, right? You grab a cactus because it looks pretty, and you stab yourself with the needles, and you're like, "Ooh, better not do that again." Right? So it'll help you and keep you safe. But and on top of keeping your body from actually getting damaged or damaging it further. What it is, you got these specialized receptors, right? More receptors that are specialized. They're different. They're specific to pain. We call them nociceptors. They're in the skin. They are in the internal organs, and they do send signals to the brain in response to something that's harmful, right? You get some kind of harmful stimuli. And again, with pain, I think you can see the direct psychological connection to this. So pain actually serves to protect the individual, right? So not to do something that's dangerous. The signal causes us to avoid further injury by not repeating what we just did. So that's like acute pain. You touch something and then you say, oh, I'm not doing it again. But you can also have things like chronic pain. And in chronic pain, it's something, chronic it means pertaining to time. So that usually means it's something that's lasting a long time. And if you're experiencing chronic pain over a long time, and again, the immediate remedies like, pain medication, ibuprofen, Tylenol, that kind of stuff doesn't seem to be affecting the reduction of the pain or inhibiting the pain receptors. That will definitely affect your mood, your sleep. Like you'll have a very affected quality of life. I won't say you'll definitely have a bad quality of life, but it'll be something to contend with continuously if it's chronic. And then what a psychologist, what they can do if the doctor can't find a way to actually minimize the actual pain, is that they'll work with individuals, and they'll work with them on how to cope with the pain. And I know that doesn't really help the physical pain that's actually there, but they'll help them at least maybe to mentally block out the pain, and be able to do some of those and have a semi-stable moment in life when they can do that. And again, this is all about how we perceive and respond to that pain. All right. Continuing with touch, all right, we're going to jump into proprioception. If you see that word highlighted there. So touching, this is essential for human beings. It's essential for all animals. There's not an animal I can think of that, maybe alligators? I'm not even sure. Like I always see alligators, they're so ornery with each other. They don't like being, near each other. There must come a time where even alligators like to be touching other alligators. Anyway, but humans do. Humans, they communicate through touching. So touching, it provides a lot of crucial development, and helps the well-being, the mental health of individuals. Going a very, very long time without any physical touch, any physical warmth from another individual, that can actually cause psychological, I don't want to say alterations. Alterations is probably a better word. Not damage, but it can cause alterations to someone's perception of caring and supporting for others. So there's a saying in Native American culture about if you remove a man from nature, so from the woods, the trees, the animals, the plant life, all that stuff, that their heart becomes hard, right? So they just become hardened toward those things of nature. And that might be true for if someone's been isolated from individuals, someone who gets no emotional support, no touch, no nothing like that, that they can psychologically start developing this compensation to not look for or require or not value that touch. And that ends up like in Native American culture, it's like when people who are distant from nature, they start disrespecting nature. They start, they don't see the value and the beauty in nature, and they start destroying nature. So in this case, with someone who's not having normal human contact, and I mean like shaking hands, anything, that they lose that ability to build relationships, those emotional bonds with others, and get to the point where they start becoming destructive with other people. Right? So because they don't see the value in it, and then it's a positive feedback that just positive, not in a good thing, positive as in it keeps feeding itself and it gets worse. So touching itself, it helps reduce stress, it helps reduce anxiety, it does promote feelings of security and comfort. So don't refrain from shaking hands with people, patting the shoulder. There's lots of things you can do that aren't too intrusive. Right? I see a lot of people doing that fist bump. Even that feels like you're connecting with somebody. But the psychological perspective for touching, this goes, it starts from infancy through your adulthood. So it contributes to that emotional and social development. So if someone who's very comfortable with like hugging, touching other people, not overdoing it, of course, this fosters a trust within that individual. It helps them become more empathetic toward others, and it gives them a sense that they're connected with others if they have that physical connection with people. So it's important for mental and emotional development of individuals. And then once they're adults, it's important for that mental and emotional stability as they're adults. So we don't all get there at the same time, but whatever adult is for an individual emotionally or mentally. Legally, there's an age for for adulthood, but obviously everyone doesn't have the exact same experiences, so someone may not reach emotional adulthood, and that might not even be a real word, or mental adulthood until a different year. Some actually, I think, are forced to get there younger, and I don't think that's healthy either. I see where kids are being pushed to excel. They want that prodigy kid who graduates with their doctorate by 12 years old, and I just think that is not normal. If it's something that's spawned within the individual and that's what they do, and they're self-leading themselves in that direction, okay, that's fine. But when you see it where it's family, parents actually, pushing children past those normal developmental stages that they need to experience, they're bypassing others, I think that's extremely harmful to the individual. So again, that's just my opinion, but you're sacrificing something. There's always a give and take. There isn't where you take the fast track and you get everything. You have to sacrifice something, and so those kids do sacrifice these normal developmental stages. So what else? Oh, proprioception. So we're going to talk about proprioception. So this is our ability to sense position, right, and movement of your body. So think back to the person who's doing yoga, blind yoga. We'll call it blind yoga, right? They get into all these positions. If you see somebody doing yoga and you don't cover your eyes, these positions look extremely hard to hold. Imagine if someone who doesn't have good proprioception and they're in these positions that and they don't know very well where their hand is placed, where their leg is placed, and they have bad proprioception, they'll probably fall over. They probably won't be able to hold those positions very well. Someone with proprioception should be able to actually hold those positions whether their eyes are closed or open. So you have these nerve cells that are located in the skin. They're also, again, I said they're located in the joints, the bones, the ears, tendons. All of this sends information to tell your body which orientation you're at, again, with respect to gravity, and where your arms, your hands, and everything is in relation to your torso and stuff like that. So, and then what your body will do is take that information, and if there's something you want to hold a position, it's essential. It's going to help you balance and stay in that task. It's super important for just basic things like walking, running. If you want to reach for an object, just reaching for an object, trying to teach a robot to reach go to a table and just grab something like a cup, that's not easy. There's a lot of things that have to happen for that. And there's a lot of information that has to be fed back to a robot just to do that. Right? If it's a robot that's going to be bipedal and stand, it's going to have to provide its own balance. So we do that, and we make it look super easy. Again, the human body is an engineering marvel. We have this spatial awareness, which helps us for all of those critical activities and navigating our environment safely. Imagine that you were at a job that required you to have, a lot of physical motion and physical motion, and you were, doing a lot of things, moving things, and there was like a very, maybe not a very complex skill, but some kind of skill that you have to, perform at your work, moving a machine, doing this, doing that. You get taught how to do it, and the first time you're doing it real slow, but your body gets much better at it, to the point where you can do it without even thinking about it. Even you can turn away, look somewhere else, and your hands can be behind you, still kind of doing the thing that you're trained to do. So that's good proprioception. That's going to be a slogan on a t-shirt. That's good proprioception. Let's talk about the vestibular system and why this is important to maintain balance and sense within our body. I call this the gyroscope, right? So it's located in those semicircular canals in the vestibular sacs inside the ear. And inside those semicircular canals, there are 3 loops of tubes within the inner ear, and they detect rotational motion of the head. So the loops actually go in 3 different positions, right? There's one that goes up and down, one that goes sideways, and one that actually detects movement back and forth. And so that actually allows us to actually, it's like the, what do you call the sensor on your phone that'll let you know where your phone's moving forward, backwards, up or down. It gives you that 6 degrees of freedom, the 6 DOF. You might have seen that with your phones. And we have this in our ear, in our brain. Well, not in our brain, but in our ear. And this allows us to sense movements, like we can turn our head, we know where our head's facing. Imagine if you didn't have that. You turn your head and you don't know where your head's facing. That's super important. We use it all the time in our phones now. But again, we were built with this system. And so I think we're better than any cell phone. Except for we can't communicate with satellites and we can't really tell where we are. But we can look at the sky and kind of get an idea of where we're at. So within those vestibular sacs, there's these two structures in the inner ear, and what they do is they sense linear acceleration. So this is like moving forward or backward in a straight line, or you change your head position relative to gravity. And the psychological relevance to this is that these vestibular sacs provide information about your body's orientation, how you're oriented in space, and what you can do to help adjust your orientation, your posture, your movements accordingly so that you can navigate or do whatever you got to do. The information is crucial for everyday activities, like if you're walking down the road and you have to avoid something and you change direction, rapidly because you're about to fall into a manhole or something. Without this, you wouldn't be able to do that very well. You'd probably continue moving forward momentumly, not making that full change, and you'd fall right into the manhole. So this is super important for you to navigate and be safe. What else? That's good. That's it right there. So I think I've beat this one to death. All right, let's talk about the experience of pain, and we'll talk about what's called the gate control theory of pain. So pain, it's a complex sensory and emotional experience because it does have an affective connection to it. So it's not just cognitively where you know you've done something, you've got information that says, ooh, this is poking me or this is burning me, it is hot. You also have this affective trait that kind of makes you feel not well, not liking it, right? You might not, whatever it is, whatever your feeling is, that it gets associated with that pain. Unless, well, there are people who do love pain, so it doesn't necessarily have to be a negative experience. I'm not one of those people who enjoys pain, but I can tolerate pain. And I'm good at sort of like blocking pain and getting through things. But it's not something I would choose to do. And there are individuals who actually enjoy pain. I don't know what that wiring looks like in that individual. Again, I don't deal with patients. I deal with just average employees. So what happens is this pain will warn you, it'll warn the brain that something bad has just happened or is about to happen. So these special receptors, we call them, remember, nociceptors, they can detect tissue damage, or they can also send you information for potential harm, and they'll send signals to the brain, and your brain does that interpretation. The psychological relevance or perspective for pain is that it serves a protection function. It alerts us to dangers like injuries, infections, or any harmful condition. And it triggers an emotional and behavioral response, such as you pull away from the hot stove, or you go seek medical attention if the pain is bad enough. One thing that we've circumvented in modern society, and you'll see this in commercials, where, again, this is not a good thing. You'll see in commercials something like, I probably shouldn't mention the medications because I'm going to put this on YouTube. A particular pain medication, and someone on the ad, whether it's an actor or it's an actual person who's experiencing the pain, they'll say like, oh, before I used to get up and my back was hurting. Every time I tried to do my job, I couldn't do this. I couldn't last more than like an hour or two at my job because my back was just really killing me. But now with this new pain medication, I can work all day. And it's like, yes and no. One, it does alleviate the pain, so you won't feel it, but you should not continue to do the activity that is exacerbating the condition which causes the pain to begin with. So you get what I'm saying, right? Um, in the commercial, one particular commercial, it was full of those types of stories. Everyone had something like, I can't pick up my granddaughter because, my joints hurt or my knee hurts or something. They got a damage in their knee. But just 2 pills of this and I can keep up with my granddaughter, all morning. It's like, no, you should take that if you're sitting down and you still can't tolerate the pain and get rid of the pain, where you are no longer going to continue that movement that's exacerbating the pain. But you shouldn't use it as a way to continue doing the motion that causes you to experience the pain. As you can see, there is still a mechanical component that people forget, that let's say they have an inflammation in the joint and they don't take an anti-inflammatory, they just take something that affects the pain and reduces the pain, they'll still continue moving and causing physical damage to those joints. And so it's a conundrum. You should really not only just take the medication, but avoid the action that's causing you to experience that discomfort in the first place. So let's talk about the gate theory control, right? So of pain, and this suggests that pain is influenced by 2 types of nerve fibers in the spinal cord. We have small fibers, and they carry pain signals to the brain, the nociceptive fibers, and then we have large fibers, and these can open or close the gate to these pain signals. So the mechanism is something like this. So within those small fibers, they transmit pain signals from the site of the injury. Say you stab yourself with a cactus pin. So at that site of injury or the damage, it gets a signal sent to the brain. The brain senses that pain is being processed. And then the large fibers, these can act like a gatekeeper. So they either allow pain signals to pass through to the brain, or they block them. So you may have heard of some people who can just kind of like work through pain. Or a good one is, not that this is painful, but have you seen the individuals who jump into ice baths, right? And some people are very sensitive to temperature, but they're able to get in there. You can tell their mind is focused on something, and they're actively focusing on blocking the sensation of that extremely cold water. So it's something like that. You're distracting your mind to prevent yourself from experiencing that full pain or that discomfort. So if you experience pain during some activities, what you can do is just stimulate the area, which will be stimulating those larger nerve fibers, and that can actually help close the gate to reduce the flow of pain. And this comes from the gate control theory of pain. So again, another personal example, and I'll bring up some personal examples, but I was working out months ago where I was doing these reverse curls, and I was actually getting much stronger. I was getting really stronger, and I love doing reverse curls. So the reverse curls are where you're doing an overhand grip with the curl bar. And then I was slowly increasing the weight, like 2.5 pounds, really, really low. And I was doing this not all at once. I knew it would take me like a month before I just even decided to increase the weight at all. And I was going extremely slow over months, just loving this workout. And one day my wrist started hurting really bad, and it actually hasn't stopped hurting. If I do any movement like that, those reverse curls, there's still a lot of pain there. And obviously, when that happens, the first thing I do is I'll squeeze the area right around my wrist. I'll start rubbing the area right around my wrist, but squeezing the wrist actually helps the best. And so what this is doing under the gate control theory of pain is that although my brain is still sending signals through those small nerve fibers to the brain to say, hey, you've agitated this wrist area, the main gate is closed, so the pain isn't actually being received by the brain, which is kind of cool. So I'm waiting for this pain to go down because I can't wait to go back to doing reverse curls. It just feels really good on the biceps. So yeah, I probably get those dopamine rushes, those dopamine hits every time I do a set of reverse curls. It also causes like your arm to have that definition, right? That you see athletes have. So doing biceps just builds that one muscle. Doing a reverse curl sort of gives that rounder, contoured kind of look. Feels good. Feels really good. So again, I'll talk about some personal things as long as I think they're appropriate for the lecture, and it's something I wouldn't mind repeating. Let's talk about experiencing pain both neurochemically and cognitively. Right? So now that we kind of understand how we can actually block pain, so when you experience pain, it's influenced both by neurochemicals, and those are related to the brain and the nerve cell activity, and it's also influenced cognitively. So this is related to thoughts and beliefs. So there's a saying in philosophy, it's a Stoic philosopher, and the saying is something like, the thought of something, like something bad, is probably worse than the actual bad thing itself, because you make it worse by overthinking it. That's not what they say, but it's kind of like what they're explaining. So it's worse in your head than it is in real life. Especially if you've experienced it before and you're focused on it. The neurochemical factors, this is where pain involves the activation of those specialized nerve receptors we talked about, the nociceptors, and that detects tissue damage, it detects potential harm, like we said, and those signals get transmitted to the brain where they're processed or interpreted as pain, right? Something uncomfortable, something you don't want to repeat. And so these neurochemical factors, they can include neurotransmitters, and they can also include hormones that affect how pain signals are transmitted and how they're received. The cognitive factors, these are our thoughts, our emotions, and beliefs about how pain can influence our experience. And so that anticipation of you're going to get a shot could be, you can cause yourself more stress from the anticipation versus the actual shot itself, which lasts like a couple of seconds, versus the entire hour going to, let's say you're heading to the doctor's office, and if you're someone who fears shots, and so you'll actually you'll cause yourself more grief from that thinking about it, that fear, that anxiety, and that can actually be more intense in some cases. But if you have a positive emotional sense, you can actually lessen that impact. So some things that people do for techniques to minimize pain is they'll use distraction techniques. They can use humor, and people use humor for psychological distraction as well. When someone's suffering and they're going through a hard time, they'll use comedy as a joking, wit to kind of make themselves not feel so bad. So if you see somebody who's just like my opinion again, who is going through a hard time, and then you hear them making jokes, and you see this I see it on TV where somebody will say, "This is not a laughing matter, and you shouldn't be laughing at that." It's like, you don't know how bad this person. It doesn't mean that person isn't actually considerate or thinking about that tragic event. It's just that's how they're compensating for it, coping for it. So it's not really good to keep them from doing the things that actually help them cope. It might be something where they just do it in private, or go somewhere where it could be offensive to someone else. It's like, hey, just you're gonna make these jokes, let's just do it over there, and I understand why you're doing it. It's a distraction technique. They can engage in other activities. They can focus on something other than the pain. So this will help reduce that perception of pain. So what I see when people jump into those ice baths, their stare goes kind of blank. So To me, it looks like they're not focused on the water at all. So it looks like they are distracting themselves, either when they jump in one of those frozen lakes or one of those pools full of ice water. Their face goes completely blank. Their expression goes completely blank. So it looks like even mentally, they're not thinking of anything. Or they might be thinking of one single thing to focus on, like something that cold water doesn't affect. Like you're just a piece of a brick or something with no sensation whatsoever, and they're kind of like just focused on that one thing. But they get this blank look when they jump in, and those are the people you see where they jump in and they have no reaction to the cold water. I've seen the others who jump into that cold water bath. You know, they do the whole thing like, whoa, they shiver and everything, and they're trying to distract by making jokes and laughing, but they're still shivering because they're trying to keep their body warm, and then they jump out right away. Versus the person who really just goes blank and they distract their mind and they get into the water, they don't move, they seem extremely calm, and so they handle it differently. Those are two different tactics. Right? Both of them allow both individuals to jump in the water, but I think the one that actually I don't know what they do. They blanket their mind, or they focus on a particular spot. It's like people who speak in who do public speaking and they get nervous, and they just normally get nervous, and there's a strategy about focusing on a particular spot in the audience. It could be a chair, or it could be just a certain point within the stadium, within the the auditorium, and focusing on that thing sort of helps them not focus on the other things. So it could be something like that. There's a lot of little techniques that help you do that, and if you can do that during crisis, this will actually help you not be affected by a crisis as much as the person next to you, if you can do these kinds of things. So it's important to understand how neurochemical and cognitive factors influence the pain perception. The pain is there, right? But how you perceive it and how you receive it is going to determine its long-term effects on you. So are you going to be someone who's traumatized by some kind of event that normally wasn't a traumatizing event for someone else or in a different generation? Or because you think about it so much, thinking about it so much is actually causing the trauma. Have you ever had a situation where you can't change something and you wish you could, right? And these are like, it's in the past, you don't think about it, but they go into this spiral, they go into this loop, and they cause themselves so much pain, and they need to learn how to like let things go. That's a good way of finding a way to distract somebody or how to cope with these things. All right, so these are the takeaways. I'm not going to read the slides as before. This is the last takeaway, and I want to thank you for your time.